Hello everyone. Now in that sessions we have to study about deep bar cage induction motor. Now the construction of deep bar double cage induction motor. The stator winding of deep bar double cage induction motor is exactly similar to that of three-phase induction motor, but a rotor consists of deep and narrow bars. In deep bar double cage rotor bar, there in two layers. Outer layer has bar of small cross sections as shown in that figure. This outer winding has relatively large resistance. The bar are shorted at both ends. The flux linkage is thus very less and hence inductance is very low. Resistance in outer squirrel cage is high and resistance to inductance ratio is also high. Now in inner layer has a bar of large cross section comparatively. The resistance is very less but a flux linkage is very high. The bars are buried in iron. As the flux linkage is high, the inductance is also very high and the resistance to inductance ratio is poor. Now, operational principle. At a standstill condition, the inner and outer side bar gets induced with a voltage and current with the same frequency of supply. Now, the case is that inductive reactance, that is XL, is equal to 2 pi FL, is offered more in deep bar or inner side bar due to a skin effect of alternating quantity, voltage and current. Hence, the current tries to flow through outer side of rotor bar as shown in that figure. The outer side rotor offers a more resistance but poor inductive reactance. The ultimate resistance is somewhat higher than a single bar rotor resistance. The higher value of rotor resistance result more torque developed at the starting, and when a speed of rotor of deep double bar cage induction motor increases, the frequency of induced EMF and current in a rotor gets gradually decreased, and hence inductive reactance, that is XL, in inner side bar or deep bar gets decreased and current face a less inductive reactance and less resistance, a whole. Now no need for a more torque because the rotor already has arrived its full speed with running torque. Now the speed torque characteristics of deep rotor induction motor. So here a torque speed characteristics or speed torque characteristics are shown in that figure. So that is a graph of inner cage and outer cage and double cage that are shown in that figure. So torque versus slip or torque versus speed characteristics are shown in that figure, where R2 and X2 are the rotor resistance and inductive reactance at the starting respectively. E2 is a rotor induced EMF and K is equal to 3 divided by 2 pi ns, where ns is the ns in rps is the speed of synchronous stator flux and s is the slip of rotor speed. The above speed torque graph shows that higher value of resistance offer a higher torque at a standstill condition and maximum torque will be achieved at a higher value of slip. Then comparison between single cage and double cage induction motor. A double cage rotor has a low starting current and high starting torque. Therefore, it is more suitable for a direct online starting. Then second, since effective rotor resistance of double cage motor is higher, there is a large rotor heating at the time of starting as compared to a single cage induction rotor. Then the resistance of outer cage increases the resistance of double cage motor. So full load copper losses are increased, efficiency is decreased. The pull out torque of double cage motor is smaller than single cage motor.